AWS certification and acts as a starting point for the other certifications. This course targets the certification exam and will provide directed study of the exam topics in several helpful ways. First, it will cover the exam logistics and detail the background knowledge needed to pass. This material will include both general architecture topics and specific AWS offerings and implementation patterns. Next, the course will explain all 4 question domains with examples, diagrams, and architectural patterns from real. In Lesson 5, we'll talk about the first 2 principles of the reliability pillar of the well-architected framework. The first of these principles, automatically recover from failure, contains several strategies that are unique to AWS for how to ensure applications maintain functionality. The second principle, test recovery procedures, relies on the AWS ability to provision temporary resources quickly and cost-effectively to verify that runbooks and procedures are correctly documented. In this section, we are going to look at the reliability pillar of the well-architected framework and its first principle, automatically recover from failure. So let's go ahead and take a look at the definition of this principle first, which is broken up into 4 parts. The first of these, by monitoring a workload for key performance indicators, KPIs, you can trigger automation when a threshold is breached. This is a great example of how AWS allows for automation and event-driven workloads. Next, these KPIs should be a measure of business value, not of the technical aspects of the operation of the service. This might be the most critical element of this entire principle, that we are looking not at the average CPU of a bunch of OS-based resources. We're looking at more important metrics, such as how much revenue we're making, or whether or not the users have a good user experience at the time. follow that with, this allows for automatic notification and tracking of failures, and for automated recovery processes that work around or repair the failure. This particular statement has a strong overlap with performance efficiency in that we are automatically replacing resources so that we can meet the workload demand. And finally, we have, with more sophisticated automation, it's possible to anticipate and remediate failures before they occur. And so here's where we have a little bit of conflict between performance efficiency and reliability, in that reliability would push you to over-provision by just a little bit so that you can absorb failure. Performance efficiency would push you to deploy exactly the number of resources that you need based on the workload demand. So let's go ahead and take a look at the first two of the 4 phases of monitoring. And we'll start with an action word, generate. How do we generate metrics and events? There are 2 examples in AWS. We've got CloudWatch and the Personal Health Dashboard. There are quite a lot of services that will push metrics into CloudWatch. EC2 pushes default metrics, but you can also create custom metrics. ECS allows you to look at default and custom metrics that have been pushed from individual containers. The Elastic Load Balancer pushes default metrics such as latency and the number of requests per second from various types. And RDS also allows for default metrics that are both generic to RDS in terms of the fact that it's running on EC2, and so you have CPU and memory, disk usage, and so forth, but also specific to the database engine that you've chosen. So let's go back to the first example here of EC2 and look at what it would take to install the CloudWatch agent that would allow us to deliver both memory and disk metrics that you can't get normally, as well as custom metrics. And that's by using the CloudWatch agent. The agent itself requires permissions and credentials. That usually translates to an IAM role that has been attached to the EC2 instance. But it also requires connectivity to the Service API endpoint for CloudWatch. And we can achieve this by utilizing the Internet Gateway, either directly from a public subnet or indirectly through a NAT gateway and a private subnet. But we can also achieve this connectivity by taking advantage of an interface endpoint for the CloudWatch service so that we can keep that traffic private. The CloudWatch agent is also supported on on-premises OS-based resources. These require static credentials, so you can't use an IAM role for these. But you can then connect to the CloudWatch Service API endpoint directly through the internet, or you could do it indirectly by going through either a direct connect or site-to-site VPN connection and then utilizing that same interface endpoint that we configured earlier for use inside the VPC itself. So let's take a look at the Personal Health Dashboard. This is not as much a service as it is just a collection of reports that are being pulled from other services. And it allows you to view the performance and availability metrics as well as outages for the underlying AWS hardware for your resources. So service outages will be delivered there. Hardware retirement events are delivered there. hypervisor reboots, and storage maintenance will all show up in that personal health dashboard. So let's move on to our second action word, aggregate. Once we've generated these various metrics, how do we get them all into a consolidated location? We have a couple of options here too. And let's focus on logs and look at a feature of CloudWatch logs, and how many different ways we can aggregate logs from various services and features there. Starting with CloudTrail. We can configure CloudTrail logs to be delivered to a CloudWatch log group. API Gateway can have access logs or execution logs enabled that deliver to CloudWatch logs. ECS containers can deliver the various runtime logs from those containers into CloudWatch logs. Lambda functions, by default, will push into CloudWatch logs. RDS and Aurora, based on the engine and whether or not you configure it, can also deliver into CloudWatch logs. Systems Manager, like run command output. So if you have issued a run command job against 5,000 instances, you could specify a CloudWatch log group as the delivery point for all of the output. And finally, your standard EC2 instances, if you have installed and configured the CloudWatch agent, those logs can also be delivered into CloudWatch logs. Welcome. In this demonstration, I'm going to show you how to configure different resilience features of Route 53. The first thing we're going to do is we're going to create a health check that is going to use aws.amazon.com as our test domain. And so if we look here, under Route 53, left-hand side, we have health checks, and we can go ahead and create one. Now the name for this, we'll call it AWS Health Check because that's actually what we're going to be checking. AWS Health Check. What are we monitoring? We're monitoring an endpoint specified by a domain name, protocol HTTPS, aws.amazon.com, and our port is going to be 443. Now this next piece is a little bit strange because it says images in there. That's really just showing you that you can add any URL after / in order to be the health check URL. We're not going to do that. We're going to leave that blank. Under advanced configuration, we're going to leave most of this in place. We're not going to do any string matching. We're going to leave it at 30 seconds. We will add latency graphs. And that's really it. We don't need to customize the regions that the health checks are coming from. And so we can just go to next. We're not going to create any alarm. We just go straight to health check. And now that's going to take a couple of minutes as it performs the first couple of tests to see if aws.amazon.com is responding properly. Now, while that's taking its time, we're going to go to hosted zones, and we are going to create our own DNS private hosted zone to use. So when we click here, we will name it test domain, and we don't need to provide a description. And our type is going to be private. And as soon as we do that, it's going to ask us what VPC or VPCs to associate it with. So we will choose the US East 1 region, and we happen to have some VPCs we can use. We'll stick with demo VPC. In addition to that, we can add tags. Hosted zones cost money, so let's add a cost center tag. And create. Now, in order to test resiliency, we want to be able to create a failover record. But to do that, we need a health check, which we've got, and we need a couple of endpoints, which we don't have. We're going to create a couple of test endpoints just using elastic IP addresses, which are public static DNS, and IP addresses to go with them. So for this, I'm going to switch back over to my terminal, and I'm going to use this script to allocate one elastic IP in each of two regions that are specified on the command line, region 1 and region 2. And you can see here I'm using the AWS CLI, AWS EC2 allocate address, domain VPC. I'm going to add a tag. And that tag is going to have a key name of Route 53 demo with a value of true, because I've also provided a script in this directory that allows you to delete them when you're done locating them according to that tag. And so we're going to create one in region 1, one in region 2. We're also going to query the public IP address, and that way we know what region it's in as well. So if we execute this script, create EIPs, we need to provide two regions, US East 1, US East 2. Excellent. So when we run into an error like that, where it says the maximum number of addresses has been reached, there's an easy way to check that. If we go back here to our VPC dashboard, AWS creates accounts and provides a 5 elastic IP limit per region. So if I go to Northern Virginia and look under elastic IPs, I'm going to find that I already have 5. And it's because I have a number of NAT gateways in our test VPCs. So in this particular situation, we will just pick one of those elastic IPs instead. And so let's move on. Let's go back to Route 53. And we've created one that we're going to use that's in US East 2. And from here, we are going to create records within our private hosted zone. So if we click on Create Record, this has quite a lot of information for us. We've got Quick Create, we've got a wizard, let's look at quick create. Well, we want to create a DNS record that is www.testdomain. Privately hosted, so there's no way we can resolve it without launching an instance into that VPC. The record type is going to be an A record, and the value is going to be the elastic IP we created in US East 2. This is what's going to become our primary record. And so we paste in the value. We can reduce the TTL if we like down to 60 seconds. And here's where the magic happens. Instead of routing policy, we have to pick something different. Failover. Now when we pick failover, we have more options. This one is going to be primary. We have to designate the health check, which we have, AWS Health Check. And then the record ID, we'll just call this the same name as the region, US East 2. We could just click on Create Records, but we need our secondary record as well. So we'll specify Add Another Record. We'll call it www.testdomain. And for this one, we'll go back to our list of elastic IPs, and we'll simply copy one. We'll paste that into the value field, reduce the TTL down to 60 seconds, and then change our failover record here. Rather than primary, it's going to be secondary instead. We associate it with the same health check, and this one we will label US East 1. And when we create the records, we'll be able to see here, if we scroll down just a little bit, that we now have two www.testdomain records. Both of them are A records pointing to different IP addresses with primary and secondary failover defined. And that completes this demonstration. In this section, we are going to take a look at the second part of the automatically recover from failure principle of the reliability pillar of the well-architected framework. And we've broken this up into 4 phases of monitoring. In the previous section, we covered the first 2, generate and aggregate. Now we're going to start with the third action word, process. And we have a couple of mechanisms that we can use to implement this. So let's start with SNS, Simple Notification Service. How can we send notifications so that we can be informed when something is happening in our environment that we didn't expect? Well, SNS can be used to send email, hopefully not to individuals and more towards distribution lists if we want to make sure that somebody is actually getting the email. SNS can be used to send messages to an HTTP or HTTPS endpoint, which might be used to create a Jira ticket. Or we could subscribe a phone number to an SNS topic so that we can send text messages to an individual who might happen to be on call. All of those previous examples have been more of a manual effort that requires someone to sit at a keyboard and actually perform work to mitigate. But can we do better? Can we automate? Well, if we create a CloudWatch alarm, we can use that to execute auto-scaling events so that we can scale based on having exceeded a threshold on a particular metric in a synchronous fashion. We could also choose to invoke a Lambda function, which might trigger a number of other possibilities that can be done through that Lambda function, executing some business logic that might be different than just regular autoscaling on EC2. Our fourth action words for monitoring would be store and analyze. Now, we've already talked a little bit about CloudWatch logs in terms of storage, but we can also configure a CloudWatch log group to retain logs based on a time to live where it can expire them after a particular period of time. We can analyze what shows up in a CloudWatch log group using CloudWatch Logs Insights, which allows us a SQL-like interface to be able to query the various log entries that show up, and we can turn those into number-based metrics and then create CloudWatch alarms from those. CloudWatch logs can also have subscribed a Kinesis data firehose delivery stream so that we can send those logs on to some other service after optional transformation, such as an S3 bucket or a Redshift database, or even an OpenSearch cluster. Now, what's interesting about this, when I say OpenSearch, is that CloudWatch logs also allow for direct delivery into OpenSearch if you're not worried about buffering and batching, and if you're not worried about any kind of optional transformation, you can just forward them there directly. While a CloudWatch log group can be configured to export logs directly to S3, that has to be done on an on-demand basis. What if we want those logs to be delivered on a regular schedule into S3? Now we have to take a look at the Kinesis Firehose delivery stream subscription to the CloudWatch log group and use it to get those logs directly into S3. And so we start with a CloudWatch log group. Then let's create an S3 bucket that will be used as our destination. We then need to create an IAM role that will allow Kinesis Firehose as the trust policy, as the principal, to be able to assume the role. And for the permission policy, we are going to allow access to be able to write into that S3 bucket as the delivery location. And so that takes care of the back half of this particular pipeline. When we create that Firehose delivery stream, we use the IAM role ARN, which is an Amazon resource name, from that previous step, and the S3 bucket ARN as well. Then we get to work on the first half of this workflow. We create a second IAM role that has a trust policy that identifies CloudWatch logs as the principal. The permission policy allows for delivery into the Kinesis Firehose delivery stream. And then we can create what we call a subscription filter on the CloudWatch log group that specifies the IAM role ARN that we just created, as well as the delivery stream ARN that we created in the previous step. And from this point on, the delivery will be based on the configuration of that Firehose delivery stream and its buffer and batch parameters that we've specified in terms of how much data can stack up versus how much time are we going to wait. On top of that, we can now utilize the SQL query engine of Kinesis Analytics to perform analytics on those log entries as they pass through the Kinesis Firehose delivery stream. Welcome. In this demonstration, we are going to take a look at DynamoDB resilience, specifically the global tables option. Now, I have already navigated to the DynamoDB console, and we're going to click here on the left-hand side, looking at tables. We have a single table called shopping cart. We're going to go ahead and select this so that we can view some of the information of this table. In fact, we can close out the navigation on the left-hand side so we can see a little bit more information. What we'll find is that we have a partition key that is just a username. Capacity is on demand. Table status is that it's good to go. And if we wanted to at this point, we could look at live item count, and we could even browse the data in the table. We have no indexes. Monitoring is just going to show us the defaults for CloudWatch. So we have our reads, we have our writes, and further down we have some latency, time to live, and different requests that have been performed against the table. Now, since this is a new table, we've not done any kind of customization. And if we go to Global Tables, we would first need to enable DynamoDB streams. That is the feature that acts as a sort of transaction log. And that is how DynamoDB actually replicates data from one region to another by consuming the contents of those streams. And so we have a couple of options. We could click on Exports and Streams and enable right here DynamoDB streams, or instead of enabling DynamoDB streams explicitly, we can actually do it as part of the process of enabling global tables. So if I click on the Global Tables tab, we see that we have no replicas. If I click on Create Replica, we have an option here for picking from the available regions. So this one is in Northern Virginia. Let's say that we would like to replicate our data to Ireland. So we select the region, and it tells you right here at the bottom, for replication to work, DynamoDB streams will be enabled automatically for new and old images. And so when I click on Create Replica, that's going to take at least a couple of minutes with a very small table like this one before it is available and ready with multiple endpoints. And it actually gives us a status here when it says creating, the capacity mode. And so we can go through and modify the table in the other regions to have slightly different performance profiles if that were appropriate according to our requirements. And that completes this demonstration. Welcome to our first question breakdown of the reliability pillar of the well-architected framework. And the first of these principles automatically recover from failure. In this question, we are going to take a look at a multiple response scenario where we are going to monitor an internal application with the ability to respond when it becomes unavailable. So let's go ahead and take a look at the question. You've been asked to design the monitoring of an internal application which runs on an EC2 instance in a private subnet, listening on port 8080. This monitoring will be used to calculate availability of the application and be used for business continuity purposes as well as automated failover. Which of the following recommendations will meet the requirement in the most reliable manner? And we have to pick 2 out of 5 to get this question correct. This question sounds an awful lot like something that you would see on the SysOps Associate exam. But because it has direct correlation with business continuity and falls under the reliability pillar of the well-architected framework, as a solutions architect, you would do well to understand all of these different services and features as well. Let's walk through these in order. A, write a script to run via cron every minute, which checks the listener port and uploads as a custom CloudWatch metric. This is a functional option. It delivers the listener uptime metrics from the instance, pushes into CloudWatch. However, executing a shell script via cron might not be an overall reliable solution. So if we can do better, we can eliminate this choice. B, configure the CloudWatch agent to push a metric which tests the listener. This sounds great, and I wish that it were possible. But the CloudWatch agent itself does not have any built-in features for supporting custom metrics. You have to use third-party tools to do that via the CloudWatch agent. So, since this isn't going to work, what about C? Provision a CloudWatch synthetics canary to test the listener port. Like A, this is a functional solution. A synthetics canary gets deployed into a VPC using a Lambda function, and it will utilize TCP or HTTP or whatever to verify that the listener is actually up. This, however, is going to be more reliable than anything we implement as a cron job. So, between A and C, we would probably choose C. But we still have a couple of answers to go, and we still have to come up with 2 correct answer choices. D, configure a CloudWatch alarm from the appropriate metric, configure a Route 53 health check with the alarm as a source. Route 53 health checks can utilize tests against public-facing resources directly, but they can also work with CloudWatch alarms as a source. This would be a functional solution, assuming that our availability metric has been pushed into CloudWatch in the first place. So let's look at our last answer. E, configure a Route 53 health check with the CloudWatch metric as a source. In D, we've already established that a Route 53 health check can utilize a CloudWatch alarm as a source, but not a metric directly. And because this does not mention the alarm, this is not going to be a viable solution. And so we can eliminate it. And now that we've looked at all 5 of our options, only A, C, and D were viable. And out of those, only C and D actually met the requirements of the question. And so we would choose those as our correct answers. Welcome to our next principle of the reliability. Only C and D Welcome to our next principle of the reliability pillar of the well-architected framework, test recovery procedures. This particular principle is going to be the one that encapsulates a little bit of business continuity and disaster recovery. Let's go ahead and take a look at the 4-part definition for this principle. First, we have, in an on-premises environment, testing is often conducted to prove that the workload works in a particular scenario. However, testing is not typically used to validate recovery strategies. Why? Because it costs. It's expensive. How, if you failed over, how do you fail back. And there's a number of other parameters that go into that. But in AWS, you can test how your workload fails, and you can validate your recovery procedures, even if you have to deploy entirely temporary resources to make this happen. You can use automation to simulate different failures or to recreate scenarios that led to failures before. This is a great reason for holding on to forensic evidence when you've had an outage to go back and replay what happened. And finally, this approach exposes failure pathways that you can test and fix before a real failure scenario occurs.
Hello, it's Duncan. I know I said there would only be one FizzBuzz episode, but then people kept on making comments on that episode and asking me questions, and HTTP benchmarking is still hard, and I just can't help myself. I like to play with code and talk about it. So today we'll go back to a blank FizzBuzz slate and use the exercise to look at a really important topic, actions and calculations, or impure and pure functions. We'll get things working as quickly and dirtily as we can, and then look at the code to help understand the difference between the different function types. Why we should prefer calculations, why actions come to dominate code unless we take action, and how to use Kotlin sequences to keep our code both pure and responsive. And oh my goodness, does this have a lot of state in it. Code katas are there to be practiced in much the same way, I guess, as martial arts katas. I might practice a kata focusing on coordination of mind and body, or on power or fluidity. The kata is the same, but my focus might be different. So this time, instead of using FizzBuzz to learn about TDD, we're going to use it to think about actions and calculations. So I've rolled back to the point where we just had the acceptance tests, and we have
literally nothing is really, really good in Kotlin. Of course, I am talking about but what does it mean? Will return us nothing, and the compiler here is happy to accept this return type. Let's say we have another function which expects to return a string. Let's call it function foo. It returns string, and we can see that, of course, we can just return an empty string here. However, we are also allowed to just return never. This happens because nothing is a subtype of string. This would also work if it is int, or any type that you can create yourself. So let's create this type foo here, request it as a return type in the small function foo, and you can see the compiler is happy to accept never as a valid return type of foo. But the real magic happens once we bring generics into the picture. Let's say we create our own result type. We call it our result, and we of course make it generic. We say it's a seal class, and we have the obvious candidates. We want to have a result that is successful, and we want to model the failure case. Therefore, we have data class success, which carries value t, and it implements our result of t. And we also want to have an error class, which is also generic type parameter t here, which also implements our result t, and it can contain some kind of throwable that represents what happened. But looking at our error class here, we notice that this type parameter t here is not necessary at all. We just carry a throwable question mark error. There is no need to know anything about this t. So we are free to remove it from our error here, and we can say that this is an our result of nothing. There will never be a value. It cannot give you something, therefore it is nothing. Let's try this in action. Let's say we want to have a function foo here, which returns us a string. And we remove this function never, and we replace it by something that is like a HTTP request, which returns us either string on success cases or some throwable or some reason why something did not work. So it's an our result of string, and we can return, like for example, our result success here. And of course we can return this HTTP request and unwrap the value. However, if we look at the code after we unwrapped the result, we see that we get an error from the compiler, which says something about incompatible types. We expect that our result of type string is coming back, and we cannot just cast it to our result of error. And the reason is because our result of error will be our result of nothing, which is not exactly the same type of our result of string, right? We need to tell this our result something about its variance. Right now, it is invariant in T, meaning when we expect some type like our result of string, we want an our result of string and exactly our result of string. Our result of nothing, despite nothing, subtyping string is not okay. We need to tell that it is okay to accept subtypes of this T to be valid here. As a rule of thumb, because in Kotlin we have in and out as modifiers for co and contra variants, my rule of thumb is if you get something out of this class, like you can read this value, you get it out, then it's covariant, you use the out modifier. If you pass stuff into this class, let's say you have a function and you pass some value of type T into this function, you use contravariance and you use the in keyword. So now that we marked this class to be covariant with this type parameter T, it is now happy to accept that yes, our result of nothing is a valid representation of our result of string, and it is able to unwrap it here, and we can just access this result.error.message. However, there's even one more cool party trick that I want to show you. It is now with inline classes and this kind of variances. Let me show you how we would write a value or function. Let's say we want to have a generic function value or on our result of t, and we say that it either unwraps it or you provide me some alternative. This alternative function will get past our result of error, and it has to provide me the value t. So we unwrap it here as well. We call alternative on this to provide the alternative value of t in case it is an error. And now the real cool magic happens once I also mark this function as inline. Let's say I want to use those functions in an arbitrary main. I can then just call this HTTP request, and I can unwrap it now using our value or function. And I can say like HTTP response equals HTTP request, value or, and now here the real party trick happens. I can just say that it should return, and it will return since it's an inline function straight out of the main function. And if we look into this HTTP response type, it is a string. And the beauty here is that not only functions that really never return something like forever looping on a while loop, but also functions like the error method or throwing an exception or the return keyword, they are treated as evaluating to nothing. They will never give you a value. Therefore, the return type is nothing. And this value or alternative closure that I have here, lambda that I provide, which just returns out of main, it will be evaluated as a type of nothing, which is a subtype of string. Therefore, it's valid to pass it as alternative to something that returns string. And you can see that in this HTTP response, I can just access this length. I can just print it to the console, and here you go. Nothing is really, really cool in Kotlin.
No implementation at all, so I guess this is going to fail. And does, splendid. I had a little chat with Dave A about whether these acceptance tests were actually complete. And his point was, well, we're only testing the first lines, these ones here. Now, I'm not convinced that it's the nature of acceptance tests that they have to test everything. After all, that would mean that we had to test every possible first name and every possible second name of all our customers. I think the nature of acceptance tests is that we agree the feature is done when they pass. Now, I suppose I could write code that returned banana for line 21, or every third Tuesday when there was full moon, and the test wouldn't capture that problem. But mostly acceptance tests aren't trying to protect us against enemy action. They're there to help us agree with our product owner when our software is done. But this, in fact, particularly isn't done, so let's crack on. I'm going to try a slightly different approach this time. We've got this capturing stood out, which, if you remember, did this system set out, which is a bit unsafe if we're running lots of tests. If we're prepared to accept a little tiny bit of risk, we can structure this differently. So what we can do here is we can say that our main is going to call fizzbuzz, passing it
and it's kind of fun and stuff. But what about if I will use something that's not running on my laptop? Especially when you do live streams, you want to use this bandwidth and the laptop power to showing some of the nice increased picture, but not slow you down of running some infrastructure on your laptop. So we're going to be using some cloud, but in a second we will talk about this in just a few seconds. Let me uncover it and also fix indentation. Another good thing, when you're dealing with YAML, you need to use the right editors that can understand indentation, otherwise you will be screwed. Now, so let's talk about this. So we do have this Spring Cloud String function definition, and this is how the Spring Cloud String will find the method that it will invoke in order to do something. With this data, and there is a binding that will create this connection to my Kafka broker that is specified in Spring Kafka properties, and specifies that this is what kind of binder I need to use and where I need to produce those messages. So we're going to be looking into a topic called facts. Number of partitions 4, use native encoding says that I will provide my serializer, deserializer. So here's the thing. Kafka really don't care about what kind of data you're putting there, but as a developer, you really do care about what kind of data you're putting there. So this is why you need to specify the serialization format. Kafka doesn't do introspection. Kafka just stores raw bytes. Yes, sir?
Vic, can you increase your volume a little bit?
My volume, of course, I can.
Yeah, people are complaining.
Now?
People are complaining.
What about now? What about
perfect?
now?
Perfect.
Yeah?
Yes, do.
Awesome. Okay, all right. So thank you for monitoring. Thank you for monitoring this the audio stuff for me. All right. So where are we talking? Where we were? So we define this function, definition of the function. So this Spring Cloud string will find this bean, and after that we'll make all this wiring to Kafka. And now I also want to have some of the clustered job. So I do have this Confluent Cloud, which is my cloud provider of my Kafka. I'm creating some basic cluster that will be running in Google Cloud close to me. I'm in New York, so US East would be closest location for me. And I would say lunch cluster. So when I started this cluster, so what's going to happen is that the cluster of Kafka would be created somewhere.
all our manufacturer's software was written in machine code, including the Algol compiler. And the great thing about machine codes in those days is that you could understand them, and if you made a mistake, you could follow through and find out what the results of your mistake have been, and so diagnose what the mistake was. But if you were using a high-level language, that capacity was taken away from you, because you no longer regarded the store as consisting of 4,096 locations, each of which, of course, were, well, 4 and 7/8 bytes long in the case of Elliott's, or in the case of other manufacturers, of course, like IBM, they couldn't
Hey,
afford
welcome to
39 bits
Grafana
in
for
each word,
Beginners.
so they only had 36 bits. But we wanted to protect our customer from knowing the details of the machine architecture. So I took it as a general principle that if anything went wrong with the code that you'd written, if you made a mistake in your program, the results of your mistake would be predictable by looking at the high-level text of your program alone. And you never had to delve into what they used to call hexadecimal core dumps in order to find out what had gone wrong and try and find out what caused it.
And in order to get this access, so I need to go here. and find a Spring Boot, and there is a template that I can use for my property file. Like I said, I usually use property files because it's more natural, but today I will be using YAML because there's a
The humble bean. Some would say that humanity owes a lot to these unassuming little fellows. Whether they be others are tendencies. They made you grow, and so do their dependencies. Certain positions, you have software objects of a certain type. Richards plays in goal. Like a team, you typically need more than one object to build an app. So instead of a team of players, you have a Spring Framework app of different software objects. Some software objects will interact with other software objects, and they will be their dependencies. Instead of a manager, you have a Spring container. Just like how a manager picks their team before they play, the Spring container creates the necessary objects at startup, providing them where they're needed, injecting them. Just like how a manager can change their team's lineup, perhaps swapping out one midfielder with a different midfielder, the Spring container can swap out objects with different objects, as long as they are of the same type. So what does this all have to do with the mighty bean? Well, those players from earlier, those software objects, they're beans. And the reason they're called beans is a little bit complicated and it needs a history lesson. You've stuck with me this far, so here goes. During the 17th and 18th century, Java was a major coffee producing region, producing an illustrious name. But what about beans? Well, there came a time where developers were creating reusable components with Java, and those reusable components needed a name. If you need to come up with a name for a reusable component using the Java programming language, and Java is coffee and coffee is beans, well, you can see where this is going. Thus, these reusable components were called beans. Fast forward even further, and you have to give a name to the reusable components in the Spring framework. Naturally, you're going to call them Spring Beans. And the rest, as they say, is history in the making, which is why you shouldn't stop here and check out the Spring Boot for Beginners course right here on YouTube and become the Spring Boot developer that you've always wanted to be. I'll see you over there.